Our topic for today is memory complexity. First, what is memory complexity? It is also known as the space complexity. It is the amount of memory used by the algorithm, including the input values to the algorithm, to execute and produce the result. Whenever a solution to a problem is written, some memory is required to complete. For any algorithm, memory may be used for the following. First, variables. These include the constant value, temporary values. Second, program instruction. And the third one is execute. Auxiliary space is the extra space or the temporary space used by the algorithms during its execution. Space complexity equals to auxiliary space plus input space. Three reasons why algorithm uses memory space while executing. First, instruction space. It is the amount of memory used to save the compiled version of instructions. The second one is environmental stack. Sometimes an algorithm or function may be called inside another function. In such a situation, the current variables are pushed onto the system stack, where they wait for their execution, and then the call to the inside algorithm is made. For example, if a function A calls function B inside it, then all the variables of function A will stored on the system stack temporarily, while the function B is called and executed inside the function A. Lastly, data space. It is the amount of space used by the variables and constants. But, while calculating the space complexity of any algorithm, we usually consider only data space, and we neglect the instruction space and environmental stack. Calculating the space complexity. For calculating the space complexity, we need to know the value of the memory used by the different types of data types variables, which generally varies for different operation system, but the method for calculating the space complexity remains the same. This is the types and their sizes. Now, let's learn how to compute space complexity by taking a few examples. This is the first example. In that expression, variables A, B, C, and Z are all integers type. Hence, they will take up 4 bytes each, so total memory requirements will be 4 times 4 plus 4 equals to 20 bytes. This additional 4 bytes is for return value. And because this space requirements is fixed for above example, hence it is called constant space complexity. This is the second example. In the above code, 4 times n bytes of space is required for the array A elements. 4 bytes each for x, n, I, and the return value. Hence, the total memory requirements will be 4n plus 12, which is increasing linearly with the increase in the input value n. Hence, it is called as linear space complexity. We should always focus on writing algorithms code in such a way that we keep the space complexity minimum. That's all for our topic, memory complexity. Thank you and good day.
So today, i-discuss natin ang worst and best case time complexity. Introduction to algorithm and analysis. So, una, define muna natin what is complexity. complexity is the quality or condition of being difficult to understand or of lacking simplicity. So, from the root word, time complexity in relation to algorithm, whereas algorithm is the series of steps or solution to a problem. So, ayan. What is time complexity? Time complexity on algorithm signifies the total time required by the program to run till its completion. So, yun. Dinidefine dito kung gaano tayo katagal or gaano katagal yung program natin provide ng solution to a problem. Yan. Time complexity of algorithm is most commonly expressed using the big O notation. So, yung big O notation ay pag-aaral natin in detail in the next tutorial. So, dito na pasok yung worst and best case time complexity. So, ano nga ba importance nito? So, by understanding worst and best case time complexity, you can choose a better solution to a problem. So, the worst case complexity of the algorithm is the function defined by the maximum number of steps. So, yun, pag worst case, yun yung maximum number of steps on any instance of size n. Kapag best case complexity naman, the function defined by the minimum number of steps taken on any instance of size n. The average case complexity naman ay a function defined by the average number of steps taken on any instance of size. So, in worst case complexity, from the root word worst, dito natin masasabi na although nakapag-provide tayo ng isang solution to a problem, pero inabot naman tayo ng maximum number of steps. So, compared sa ideal, which is ito dapat yung atin na ginagawa kapag may mga problem, is yung best case complexity, yung pinaka-ideal na pag-provide ng solution to a problem, defined by the minimum number of steps. So, minimum number of steps, pero makakapag-provide ka pa rin same solution to a problem. So, yung sinasabi dito curve ay papakita namin sa isang graph. So, yan pa yung ibang example ng worst case complexity, most time-consuming computation, maximum number of steps. Samantalang yung best case complexity, less time-consuming computation, minimum number of steps, and the same result as the worst case. Ang pinagkaiba lang nila, yung worst case ay mas maraming computation, solution ay process, and time-consuming siya. Yung best case naman, less time-consuming, and minimum number of steps, but the same result. Yung average case complexity, ito yung average value of difficulty defined by the average number of steps taken on any instance of size n. Yung size n na sinasabi dito is a constant. Magdedepende yung size, depende sa mismong program na ating gagawin. So, para mas maintindihan natin, let's put it on a graph. Ayan. So, medyo malabo. Pero dito nila sa y-axis is yung time. Sa x-axis naman is yung steps. So, kung makikita natin, ay baliktad pala. Sa y-axis yung steps. Sa x-axis yung time. So, kung makikita natin, yan, worst case, as the steps goes up, the time goes up din. So, parang directly proportional. Since marami kang step na kailangan gawin, kailangan i-provide, mas time consuming. Doon napasok ng worst case. Average, nasa minimal stage of difficulty lang, minimal steps, minimal time yung ginagamit mo. Kapag minimum, konti lang yung step na ginagawa mo, and less time consuming siya. So dito natin makikita na although konti yung step, konti din yung time ng pag-run ng program, same solution pa rin yung mabibigay ng ating program. Yan. For example, find square of a number n, where n is a constant to be inputted by the user. So, masasabi natin siyang worst case because gumamit siya ng for loop. Yan, nakikita nyo. Nag-loop pa siya into a number, sabihin natin 4. Nag-loop pa siya at 4 para lang makuha niya yung square. Ayan. Masasabi natin for loop kasi gumamit pa siya nito. Although marami namang solution na mas konti dito. So, masasabi na siyang worst. Sabihin natin very time consuming siya compared dito sa next example natin, which is the best case scenario para sa paggawa ng square number. Ayan, tulad nito, ginamit niya lang yung input user, multiply niya by itself, makukuha na natin yung value ng square. So, marami pa tayong pwedeng example, tulad ng paghanap natin ng isang bagay sa isang list, diba? Imbis na isa-isahin natin yung mga bagay sa isang list na yun, pwede tayong gumamit ng ibang paraan. Sabihin natin, kukuhain natin yung median ng list, yung middle ng list, then i-test natin kung yung hinahanap ba natin ay nasa less than, nasa left side or nasa right side. If yung hinahanap natin is nasa left side, so doon lang siya mag-focus. Mas less yung pag-consume niya ng time at mas less yung process. So, yun lang ang best and worst case time complexity. So, tandaan natin kapag worst case time complexity, time consuming, and mas maraming steps. Pag best case, ito yung pinaka-ideal na pag-provide ng solution to the problem, which is less time consuming, and less series of steps, but the same output. Ang same output or the same solution lang. Yun lang. Thank you.
Our topic that we will discuss is complexity classes. First, what is complexity classes? A complexity class is the set of all the computation problems which can be solved using a certain amount of certain computational resources. It helps computer scientists group problems based on how much time and space they required to solve problems and verify solutions. There are some common complexity class. First, NP class problem. The set of all decisions based on problems came into the division of NP problems who can be solved or produce an output within polynomial time but verify in polynomial time. NP class contains P class as a subset, NP problems being hard to solve. The second class is P-class problem. The set of decisions based on problems come in the division of P problems who can be solved or produce an output within polynomial time. P problems being easy to solve. The third one is polynomial time. If we produce an output according to the given input within a specific amount of time, such as within a minute or hours, this is known as polynomial time. The next one is non-polynomial time. If we produce an output according to the given input but there are no time constraints, is known as non-polynomial time. But yes, output will produce but time is not fixed yet. The next problem is decision-based problem. A problem is called a decision problem if its output is a simple yes or no, or you may need this of this as true, false, 0, 1, accept, or reject. We will place many optimization problems as decision problems. The next one is NP-hard class. Here you to satisfy the following points to come in the division of NP-hard. First, if we can solve this problem in polynomial time, then we can solve all NP problems in polynomial time. Second, if you convert this issue into one form to another form within the polynomial time. The last one is NP-complete, when it can be solved by a restricted class of brute force search algorithm and it can be used to simulate any other problem with a similar algorithms. The following table summarizes the most important complexity classes and their properties according to the current understanding in the field. Solvable in polynomial time defines decision problems that can be solved by a deterministic Turing machine, or DTM, using a polynomial amount of computation time. Its running time is upper bounded by a polynomial expressions in the size of the input for the algorithms. Solution variable in polynomial time defines decision problem for which a given solution can be verified by a DTM using a polynomial amount of computation time, even though obtaining the correct solution may require higher amount of time. Reduce any NP problems in polynomial time. Define decision problems whose algorithms for solving them can be used to solve any NP problems after a polynomial time translation step. That's all for our topic complexity classes. Thank you and good day.